Hi friends, hope you all are safe at home. I am Joshna. I am here to discuss about the experiment. Determination the concentration of soft drinks using strong base by both pH metric and conductometric titration. Actually, I did this project along with my classmates Yuvraju, Sai Kiran and Ajay. Hi friends. First of all, let's have a brief look about the introduction of this project. Soft drinks. These are very commonly known. There is no age limit. People show their love towards them. The points in this slide describes the history of soft drinks. Soft drinks. The era of soft drinks began in 1952, but the industrialization in India marked its beginning with launching of Limca. Since the beginning of soft drinks was highly profitable and luring, many multinational companies launched their brands in India. Why people show their love towards them? Did you know what soft drinks are actually made up of? For this, have a glance over the slide. Composition of soft drinks. Soft drinks of different brands are mainly composed of alcohol, carbohydrates, carbon dioxide, phosphate ions, etc. Most carbonated drinks, which are approximately have 94% water, which have pH around 2.5 to 3.5. Most of the soft drinks contains 150 calories per 12 ounce. Most of the calories in soft drinks are in the form of refined sugar. All the soft drinks conduct electricity as they form ions in water carries charges. Although electricity is conducted, only small current pass through them. Movement of electrons is not sufficient to cause the bulb to glow. We completed this project using some soft drinks like Pepsi, 7-Up and Mountain Dew. This slide describes about Pepsi. Pepsi is one of the most well-known brands in the world. Pepsi has concentration of 7.6 or 17 mg per 100 ml of cola. Pepsi has pH level of 2.53, which means it is acidic. It means it has same pH of stomach. Pepsi is acidic in nature, so it exhibits conductivity. This slide describes about 7-Up. 7-Up is an American brand of lemon lime flavored non-caffeinated soft drink. It has pH level close to 3.79, making it acidic. High fructose corn syrup is used to give its signature sweet taste. It has a citric acid, so it exhibits conductivity. This slide describes about Mountain Dew. Mountain Dew is carbonated soft drink brand produced and owned by PepsiCo. The original formula was invented in 1940 by Tennis beverage bottlers Benny and Ali. The pH level of Mountain Dew is 3.3. Its flavor is citrus. It exhibits conductivity due to the presence of citric acid.
Now we discuss about literature review. The literature review about the soft drinks. We discuss the literature review is completely based on the experiments of pH meter titration and conductometric titration. Now we discuss the review of soft drinks and dental health. Is the review of the current literature. Shall we start that? In recent years, there has been increased interest in the role of commercial soft drinks in dental diseases, namely as dental caries and erosin. The objective of this paper has been to review the past and current literature to determine the present knowledge on this subject. Nowadays, the most available drinks in Pepsi, 7-Up and Mountain Dew and so many are there. But mostly we use as Pepsi, 7-Up and Mountain Dew. Pepsi is one of the most well-known brands in all over the world. Pepsi drinks available in 200 countries. We also know that the pH of stomach is 1.5 to 3.5. Nearly the Pepsi pH is 2.53. The value is calculated our chemistry lab because of our project is soft drinks. Then we experiment on soft drinks in pHmetry. Then we determine the values of some soft drinks. Then it nearly adds same pH of stomach. Then it gets broken down and mixed with other substance in our stomach. The pH of Pepsi is 2.53, so that it is acidic. Then cures the dental diseases. The 7-up the pH is 3.79, so it is also acidic and cures of dental diseases, and it has high content of fructose. Then causing heart tension, hypertension, and blood pressure increase in our body. The pH of Mountain Dew is 3.3. It also is acidic. These all drinks are damage our teeth. The literature related to dental caries, erosin, drinks, soft drinks, and fruit juices was revived. The literature shows efforts have been taken to modify soft drinks by either adding or deleting certain components so as to reduce their harmful effects on teeth. A rational protocol to encourage the sensible use of drinks and the modification of drinks to render them less harmful would be advisable. The review was about the studied the J.F. Tamseby et al. And J. Bent in 2006 January. The another article about soft drinks is the commercial soft drinks pH and in vitro dissolution of enamel. Then the abstract is most soft drinks are acidic in nature and exposure to these drinks may result in enamel erosion. This study sought to measure the pH of 20 commercial brands of soft drinks. The dissolution of enamel resulting from immersion in these drinks and the influence of pH on enamel loss. Comparison of the erosive potential of cola versus non-cola drinks as well as regular staggered and diet versions of the same brands was undertaken. The pH was measured immediately after opening the soft drink can. Enamel slices obtained from freshly extracted teeth were immersed in the soft drinks and weighted at baseline and after 6, 24 and 48 hours of immersion. Non-cola drinks add significantly higher pH values than cola drinks but showed higher mean percent weight loss. By contrast, staggered versions of the cola and non-cola drinks showed significantly lower pH values and higher mean percent weight loss than their diet counterparts. The pH values of the soft drink did not have a significant influence on the mean percent weight loss. Prolonged exposure to soft drinks can lead to significant enamel loss. Non-cola drinks are more erosive than cola drinks. Sugared versions of cola and non-cola drinks proved to be more erosive than their diet counterparts. The erosive potential of the soft drinks was not related to their pH value. The review was studied by the Poonam Jain et al. Gendent in 2007 from March to April. The another article about soft drinks is soft drink consumption and carries risk in children and adolescents. The abstract is soft drink consumption has increased dramatically in the United States over the last 2 decades. This increase in the consumption of soft drinks has led to a decrease in daily consumption among children and adolescents and increase the risk for dental caries and a host of systematic complications. This paper addresses the changing consumption of B averages among children and adolescents, the health consequences of such a change, and a new carries risk assessment tool that can be utilized in a private practice setting. This review was studied by Jonathan D. Sankin et al. The Gendent in 2003 from January to February. The another article about soft drinks is sports drinks and dental erosion. The abstract is to discuss the composition and rationale for use of sports drinks along with recent studies investigating the relationship between sports drinks and dental erosion. A review of the literature of sports drinks and dental erosion was done. For most athletes and individuals engaged in physical activity, the use of sports drinks does not provide a benefit over water. Furthermore, although there is much in vitro evidence that acidic drinks such as wine, fruit juices, and carbonated soft drinks have erosive potential, and there are relationships between consumption of these drinks and erosion. Only one study has reported an association between sports drinks and dental erosion. Other factors such as drinking habit and salivary production may be more important determinants of dental erosion. The review was studied by Jeff S. Combis, M.J. Dent in 2005 from April. The another article about soft drinks is dissolution of dental enamel in soft drinks. The abstract is a high percentage of the population consumes a variety of soft drinks on a daily basis. Many of these soft drinks contain sugar and various additives and have a low pH. This study compares enamel dissolution from both regular and diet B averages. For example, the 7-Up contain the high content of fructose. This causing heart tension, hypertension, and increase the blood pressure on our body. And also know that the 7-Up, the pH is 3.79. Then it is a acidic. Then cause the dental erosion. The review was studied by J. Anthony van Frenhofer et al. Gendent in 2004 from July to August. The another article about soft drinks is dental erosion and severe tooth decay related to soft drinks, a case report and literature review. The abstract is soft drinks have many potential health problems. The inherent acids and sugars have both acidogenic and carcinogenic potential, resulting in dental caries and potential enamel erosion. In this report, we present a 25-year-old man complaining with the severe worn out of the front teeth during the past 3 years. He had a history of drinking cola for more than 7 years and had a poor oral hygiene. Severe decays were present in the incisors and the canines, while less severe lesions were noted on the premolars and the molars. The review is to show the relationship between dental erosion and caries and soft drinks. Some efforts have been taken to reduce the harmful effect of soft drinks. To see the figure, the review was studied by the Ran Chang et al. J. Jahingang Univ from 2009 May.
Experimentation. In this slide we will discuss about how to do experiment and how to determine the concentration of soft drinks using strong base by using pH and conductometric titrations. Objectives: compare the results obtained with true value. Principle: the neutralization reaction takes place between soft drink and NaOH. pH metric titrations of soft drink with NaOH. Step 1: preparation of standard oxalic acid solution and calculate the molarity of oxalic acid solution. Step 2: standardization of NaOH or preparation of secondary standard solution and calculate the molarity of NaOH solution. Step 3: 10 ml of Pepsi is added in a beaker and also 40 ml of distilled water is added in it. Step 1: 10 ml of Pepsi is added in a beaker and also add 40 ml of distilled water in it. Put the beaker on pH meter in which the Step 1: 10 ml of Pepsi is added in a beaker and also add 40 ml of distilled water in it. Put the beaker on pH meter in which the glass electrode is immersed without touching the bottom. The titrant NaOH is added from the burette. With continuous stirring and stable values of pH is obtained with each addition of NaOH from the burette. We will observe that there is a sudden change in pH from acidic acid to base. So we will observe that there is a neutralization reaction takes place. Repeat the experiment. In place of Pepsi, we will take 7-Up and Mountain Dew. Repeat the process. Conductometric titrations of soft drink by using sodium hydroxide. Step 1. Preparation of standard oxalic acid solution and calculate the molarity of oxalic acid solution. Step 2. Preparation of secondary standard solution of NaOH and calculate the molarity of NaOH. Step 3. Take 10 ml of Pepsi and add it in a beaker and add 40 ml of distilled water in it and put the beaker on conductometer in which glass electrode is immersed without touching the bottom. The titrant NaOH is added from the burette with continuous stirring and stable values of pH is obtained with each addition of NaOH. We will observe that there is a sudden change in conductance. First, conductance is decreased at a particular point. The conductance will gives increasing. The particular point at which the conductance is increased, that point is called equivalence point. Observations for Pepsi, both pH metric and conductometric titrations. First picture, we observe that observations for Pepsi. Serial number, volume of NaOH is added, pH value, change in volume delta V, change in pH delta pH, change in pH by change in volume. In this case, each time we added 0.1 of NaOH from the burette. It is called accurate titration. Accurate titration are used for performing. We will get accurate pH. For this purpose, we were used accurate titration for measuring accurate pH. In this second picture, we observe that serial number, volume of NaOH, conductance and corrected conductance. Calculations for Pepsi. pH metric M1, molarity of Pepsi, let it would be the XA. M2, molarity of NaOH is equal to 0.5158 molar. V1, volume of Pepsi equal to 10 ml. V2, volume of NaOH equal to 1.2 ml. N1, number of moles of Pepsi 1. N2, number of moles of NaOH 1. By using M1 V1 by N1 is equal to M2 V2 by M2, we will calculate the molarity of Pepsi as 0.06189 molar. Calculations for conductometry. M1, molarity of Pepsi, let it would be the XA. M2, molarity of NaOH is equal to 0.541 molar. V1, volume of Pepsi 10 ml. V2, volume of NaOH is equal to 1.5 ml. N1, number of moles of Pepsi 1. N2, number of moles of NaOH 1. By using formula M1 V1 N1 is equal to M2 V2 by N2, we will get the molarity of Pepsi as 0.1082 molar. Observations for 7-Up. Observe first in this first picture. Observe the values of pH for 7-Up. Serial number, volume of NaOH is added, pH value, change in volume, change in pH, change in pH by change in volume. Each addition of 0.1 ml of NaOH corresponding pH is observed. In this next picture, the conductance of 7-Up. Serial number, volume of NaOH rundown, conductance and corrected conductance. By each addition of 0.5 ml, we will get the conductance. In this first picture, we will observe that every addition of 0.1 ml of NaOH is added. It is accurate titrate for measuring accurate pH. In this slide, we will discuss about the calculation of molarity for 7-Up by using potentiometric and conductometric titrations. First, we will observe that pH metry. M1 molarity of 7-Up, let it would be the XA. M2 molarity of NaOH is equal to 0.5158 molar. V1 volume of 7-Up equal to 10 ml. V2 volume of NaOH equal to 1.1 ml. N1 number of moles of 7-Up 1. N2 number of moles of NaOH 1. By using formula M1 V1 by N1 is equal to M2 V2 by N2 by calculating the molarity of NaOH. In this second picture, we will observe that the conductometry M1 equal to molarity of 7-Up, let it would be the XA. M2 molarity of NaOH equal to 0.541 molar. V1 volume of 7-Up equal to 10 ml. V2 volume of NaOH equal to 1.1 ml. N1 number of moles of NaOH 7-Up equal to 1. N2 number of moles of NaOH equal to 1. By using formula M1 V1 by N1 equal to M2 V2 by N2, we will get the molarity of 7-Up as 0.1082 molar. Calculations for Mountain Dew. First picture, we will observe calculation of molarity for Mountain Dew. Graphs. First graph, we will observe that the pH metry for Pepsi. We will observe that delta pH by delta V is taking on y-axis and the volume of NaOH is taking on x-axis. The graph is plotted. In this graph, we will observe that first pH is decreases at a particular point. The pH source increases. There is a sudden change in pH from acidic range to basic range after completion of the neutralization reaction. Observed in case of conductometry, the graph is plotted between NaOH and corrected conductance. Taking corrected conductance on y-axis, NaOH on x-axis, the graph is plotted. We will observe that the first conductance is decreases soon after neutralization. The conductance increases. The point at which the conductance is increased, that point is called equivalence point. Graphs for 7-Up. Graphs for Mountain Dew. Results and discussions. By completing this experiment, we will observe that the conductance of Pepsi is greater than when compared to the conductance of 7-Up and Mountain Dew due to two reasons. Pepsi contains strong acid phosphoric acid. But in case of 7-Up and Mountain Dew, the weak acid citrus acid is present. We know that the strong acids will have more dissociation constant. The substances will have which has more dissociation constant will exhibits more conductance by dissociates ions. So that reason strong acid phosphoric acid the degree of dissociation is 0.8, which is nearly equal to 1. In case of citrus acid the dissociation constant alpha is equal to 0.4, so it is very less than when compared to the phosphoric acids. So that reason phosphoric acid conducts more conductance when compared to the other two. And the second reason is the phosphoric acids will have more the phosphoric acids which has a more equilibrium constant, that is 7.3 into 10 to the power of minus 3. In case of citrus acid, the equilibrium constant is 7.4 into 10 raised to the power of minus 4. We know that the substances which has more equilibrium constant, it conducts more due to it dissociates ions easily. So that reason Pepsi exhibits more conductance when compared to the other two. So this is the result and discussion about conductometric titrations. In case of pH metric titrations, the pH of strong acids it is very less, just like 1 to 3. So the Pepsi contains phosphoric acid. The pH of phosphoric acid is 2, so it is a strong acid. So strong acids will have lesser pH, and the citrus acid the pH is 5. So we observe that the strong acids will have lesser pH. Lemon has a By this experiment we will observe that lemon has a pH of around 2.5. This is the results and discussions of conductometric and pH metric titrations.
Conclusion. By completing the project, we concluded that different soft drinks has different pH levels and conductometric levels. The common ingredient in above beverage is citric acid. Pepsi contains phosphoric acid comparing to remaining soft drinks, which is very dangerous to health, and its pH level is low, so it's highly acidic. Drinking high amounts of sugar sweetened beverages such as soda can have various adverse impacts on health. If sufficient contains strong acid or strong base, exhibits higher conductivity when compared to weak acids or bases. References. Here are the references for this project, and we completed this project under the guidance of Pavan sir. Contribution of team members. Literature review, experiment, result, analysis, report writing for pH metric titration done by Joshna and Yuvraju. Experiment, result, literature review, analysis, report writing for conductometric titration done by Sai Kiran and Ajay. PPT was done by Joshna, Yuvraju, Sai Kiran and Ajay.